Good morning, students. So we will discuss today. We are going to start relation. Okay. So previously you have seen the last part one topic was based on Cartesian product, and that was an introduction to this relation. We learned Cartesian product. We also learned the ordered pairs, how they work and how they are formed. So today is part two. We see relation. Okay. So these are the topics like definition. We will learn. We will see what is actually a relation is. Then the domain and the range, and also the codomain of relation, and then inverse relation. These things we are going to learn. So what is it? Say, let us consider two sets. Okay. So set A and set B. So we are going to write a relation. We are going to write a relation from set A to set B. Please look at the expression. So this is how generally we represent this. So we are going to write a relation from set A to set B. So let us write a few elements over here. Say 1, 2, 3, 4. And here I write something like 5, 6, 8, 10. So as you know that these elements are x elements and these elements are y elements. So these are the general representation. That means set A elements x. So say x belongs to A, like that. And set B elements, general representation, we take the variable to be y. So y belongs to B. So I will write some relation like say y equals to x plus 4. Y equals to x plus 4. That means if you do this kind of operation, if you add 4 with x, you are going to get y. So how the connection will be? These are the x elements. So if you add 4 with this, you are getting 5. So this will be connected. Okay. So this is connected. Then again 2 to 6, it will be connected. Why so? Because if you put 2 over here, you will get 6. Then 3 plus 4, it becomes 7. 7 is not there, so we cannot connect. Then 4 to 8. Okay. So here we stop. Then this 10 is also left in the set B, that is not connected. Okay. So this is a relation. Okay. This is a relation given by which the elements of set A are connected with set B. The relation means that is the condition given by which two sets or the elements of the two sets are connected. So we can write this R. So let us write R1 instead of R, because see R can give you put into some confusion, like capital R also stands for real numbers. So I suggest you to write R1, R2 like that, so that you can avoid this confusion. So this capital R bold and this relation are not mixed with each other. So here what I will write only the connected ordered pairs. That is 1, 5, 2, 6 and 4, 8. So why do I write these ordered pairs only? It's only because these ordered pairs, they follow the condition given above. The condition is y equals to x plus 4. The condition, this condition y equals to x plus 4 is actually obeyed by these ordered pairs. That's why we put them. So you have seen relation means it relates two sets, one set with another, with the help of a condition. Okay. So now we see relation in much more details. So let us see. So what is a relation? What is a relation? So in simple senses, if you want to write that what is a relation, okay, one second. Okay, in simple senses, if you want to write what is a relation, we write that it is a set. Okay, it is what? It is a set. Look at it. It's a set. But it is it's a different type of set. It's a set of what? It's a set of ordered pairs. So this is the additional thing which we write. It's a set of ordered pairs. Okay, that means ordered pairs we wrote over there. It's not the simple set like this. A equals to, say, what we took 1, 2, 3, 4, and B equals to 5, 6, 8, 10. It's not simple as this. It's a special set of ordered pairs. Okay. Now second point is it has a condition. It has a condition. So what condition, that also you know. Here a condition is given. Something is defined based on which the elements are chosen. So that y equals to x plus 4 is what? It's the condition. So it has a condition. The third point is you can say it has a source. It has a source. Okay. That means from where you are going to get the elements. This A and AB, A and B. So these are the source. So what is the source? We call the source as the Cartesian product. Okay. So now we see that A cross B comes from what? Crossing this A and B. So how many elements will be there? A cross B will be having 16 elements, or you can say 16 ordered pairs. Okay, 16 ordered pairs. Now what are these ordered pairs? These ordered pairs are elements like 1 5 or 2 6 or 1 6 or many 1 8, many 16 ordered pairs. So what we know, that out of those 16 ordered pairs we have selected only 3 ordered pairs as per the given equation or as per the given condition. So that means we have here the condition, we have here the source from which we are deriving this particular relation R1. Okay, so that means this is a source, it needs a source, it needs a condition. So we can write the fourth thing, that R, that means the relation R is actually a subset of A cross B. R is a subset of A cross B. Why so? Because you are getting a few elements or few ordered pairs from here, putting them, writing them as R1. So R1 must be what? R1 must be a subset of A cross B. Okay. Now, if we try to write another relation, there is a little space, I'll write it over here. If we try to write another relation, say something like say R1, this is R2, I write R2, say y equals to, y is greater than x plus 5. Y is greater than x plus 5. That means you have to connect all those ordered pairs into it. So here I wrote what? This is R2. Okay. So obviously the same elements will not get connected. So if you put 1 plus 5, 6. So elements which is greater than this side. Okay. So you have to put those elements. So what can we put 1 and 5? No, 1 and 5 will not be connected. Even 1 and 6 is not, but 1 and 8 possible. Right. Why so? Because if you put 1, you get 6 over here. Now 8 is bigger. So again 1 and 10 possible. Okay. Again if you put 2 over here, you get 7. So something bigger than 7, that means 2 8 is possible. Okay. If you put 3, 2 10 is also possible. Okay. If you put 3, it becomes 8. That is not possible. Only 3 10 is possible. Okay. And if you put 4, now 4 plus 5 9, only 4 10 is possible. So what we got? We got things like 1 8, we got things like 1 10, we got things like 2 8, because if you put 2 it will be 7, you get 2 10, and you get what else? 3 10, and 14. Okay, so these are the elements. Just put it in over this in equation. We got as what? This is R2. But check it out. These are the elements, or these are the ordered pairs which are already present in A cross B. Okay, that means A cross B is the source, or A cross B is the reservoir. So you can say that R2 is also a subset of A cross B. So many relations could be possible. Many relations could be possible from a single A cross B. That means the Cartesian product. So next question is, how many relations possible? So how many relations possible means the number of subsets possible will be the number of relations. So it is the same concept. If you remember power set, that means power set also describes that it's the number of subsets out of a given set. So here also the number of subset you have to find. So how many elements are here? 16 elements. So number of subsets will be 2 to the power 16 over here. So how many relations possible? Here the relations possible will be 2 to the power 16 relations. This many relations possible. Okay. So this formula is actually 2 to the power mn. What is 2 to the power mn? Where m is the cardinality of A, n is the cardinality of B. That means you can take these elements, any of these elements, so 2 to the power 16 relations possible. Okay, so now we will see a little bit of the domain and range for the relations. So I'll erase a part. So this part I'll erase up, the definitions and all. Okay. So we have two relations. I'll write it a little better way. So this is what? This is R2. Okay. And this part also I will erase out. Okay. So now I will discuss the domain and range of relations. Now look at the what is domain? Domain is domain of R1. You can easily understand. It's the collection of all the X elements. Okay. Or you can say it's the set of X elements in R1. So what are the X elements? You can see 1, 2 and 4. So the domain is what? Domain is a set. It will be 1, 2 and 4. So this is the domain of R1. Now range of R1. Range of R1 is what? Is the set of the Y elements in R1. This is the set of the Y elements in R1. So it will be 5, 6 and 8. The set of Y elements in R1 will be 5, 6 and 8. Similarly for R2 also you can get domain of R2. Is the X elements you get what? 1, then 2, then 3, 4. Okay, so 1, 2, 3, 4. That's the full set we are getting. And the range, we will get the next elements, that is 8 and 10. So range of R2 will be 8 and 10. So hope you got that the domain will be the first elements, X elements, and range will be the second, the element of the ordered pair, that is the Y elements. Okay. After this we discuss codomain. After this we discuss the codomain. So what is codomain also? So codomain. Okay, so can you see codomain? I don't think so. So this is codomain. Okay, just a second. Codomain. Codomain of, first of all we will write R1. Codomain of R1. Codomain of R1 is what? Always remember, codomain of R1, it's actually very easy to get. It's the second set of the Cartesian product. It's the second set of the Cartesian product. That means it's only B. 5, 6, 8, 10. So Cartesian product was what? A cross B. Cartesian product was A cross B. So what is the second set? Second set is B. So the codomain will be B. Here also if you get, look at this, it's the source A cross B. So the second set of the Cartesian product, you can say that is the codomain. Here you also get codomain of R2. That will also be B. That means same the second set always. So range and domain you got is the specific elements that are inside the set, that are there in the set, but the domain, the codomain is the second set of the Cartesian product. Now we will discuss the inverse relation. So inverse relation, I'll clear out a few part of this and I'll show you the inverse relation. Okay, the inverse relation is written as, for say R1, the inverse relation will be written as R1 like this, R1 inverse. This looks like its notation is like R1 to the power minus 1. Okay, so that is how it is written, that is how it is represented. So it's R1 inverse, so inverse relation. So it's nothing but you have to just swap the elements. So it will be 5, 1, 6, 2 and 8, 4. So this will be R1 inverse. So obviously the domain of R1 inverse will be what? It will be 5, 6, 8. So it will be same as the range of R1. So these are same. Always you remember, domain of R1 inverse will be 5, 6, 8 will be same as range of R1. And obviously the range of R1 inverse will be 1, 2, 4. So that will be same as this thing. So this is the range of R1 inverse. Range of R1 inverse. That means you get the range as what? Second elements 1, 2 and 4. So domain of R1 is equal to range of R1 inverse. Then range of R1 is equal to the domain of R1 inverse. Let us write R2 inverse also. R2 inverse, I'll write over here. R2 inverse, if you write, it will be same kind of thing. Only the elements will be swapped. That is 8, 1, then 10, 1, then 8, 2, 10, 2, 10, 3, then 10, 4. Look at it. So this is the R2 inverse. Same thing. So you get the domain as 8 and 10. So domain is 8, 10. So that will be the range of R2. So this is the domain of, you can say, R2 inverse. And the range of this, which is 1, 2, 3, 4, will be equal to the domain of this. Okay, so it's the range of R2 inverse. So this is the inverse relationship. Inverse relationship is the same relation you get just by swapping the individual ordered pairs. Okay, next part we will see function and we will do sums on this also. Thank you.